F5. Oh. Oh, we've already done most of this. Hold on. Let me skip down to where we were. You got all of that? Let's move on. Oh, sorry. Yeah, if you're done with it, turn it in. If you're not done with it, turn it in anyway. All right, so let's see here. We talked about, I drew a diagram for you where we had moles in the middle. And we had, I can't remember which one was on which side, but like on one side was mass, and the other side was count. You're going from moles to count. What did you do? You multiply by Avogadro's number. You're going the other direction. You divide. You're going from moles to mass. What do you do? Multiply by molar mass. Going the other direction. You divide by molar mass. Now we're going to add another level to this. The diagram up on the board is. Yeah. So please don't hurt each other. Here. Use another pencil to push it out. Right. So use another piece of lead. Oh. All right. Fine. I'll fix it later. So mole to mass. We talked about that. That's what I have here. Right. Mole to mass. So you do a conversion. Now we can also go from moles to volume of gas. What was that conversion? Going from moles to volume, multiply by 22.4 liters per mole. Going the other direction, divide by 22.4 liters. Well, divide by 22.4 liters per mole, or multiply by moles over 20. Wait, what do you mean? The number of moles? So if I have the number of moles, and I'm trying to find the volume, I multiply the number by 22.4 over 1. Yes. So if I have moles, let's say I have 3 moles, and I want to find the number of liters, I multiply it by 22.4 liters divided by 1 mole. Moles cancel, and I get whatever that number is, 67.2. Okay. Now, if I had said I had 67.2 liters, and I want to get my moles, what do I do? Divide by 22.4 over 1, which is 22.4 liters and 1 mole up here, which happens to be 3 moles. Look at that. All right, so that's another start. Now, we've already talked about this one as well, where we've gone from moles to representative particles, which is my piece over here. So, here's my mole roadmap. If I give you volume of gas and I want you to find the count, what do you do? Starting here, you convert volume into moles, and then how would you find count? Convert moles into moles, convert to count. Now, if I gave you the mass and I wanted you to find the volume, what would you do? Convert to moles. Convert to moles, and then go from moles to volume. This is something you will do many, many times in chemistry, both here and chemistry after this. So, in heaven, we might be able to do this in our head. No calculators. So, calculate the mass in grams of a sample containing that many molecules of water. So, we're starting at molecules. We're going to mass. Go for it. Grab a piece of paper. Oh, no. Oh, this is what you're asking? Yeah. So this is going from moles. This is going from liters to moles. Let's see here. You looked at the answers in the back yet? That's close. But you have to multiply by the molar mass. We're trying to find grams. That's why they put that one up there. Do the math. Yes. You have to multiply by the molar mass. It's 18. Water. Yeah. So who has the answer? Raise your hand if you have the answer and didn't look at the other pages. Hey, I have to clarify my question. How many of you are actually working on the problem? How many of you are lost? Okay, so let me see if I can clarify where we are.
Got it.
Yes, it's on your on the I gave you a copy of this someplace.
See 5.5327.
It's 4 from the end, 5 from the end, something like that. Nice. So we have count. We have this 1.85 times 10 to the 34th molecules, right? What do I multiply that by? 6.022 times 10 to the 23rd. Because notice I'm going from count to moles, so I divide by Avogadro's number. 1 mole. Okay. Then what do I do? 18 grams per 1 mole. Gives me moles cancels. This is molecules. Those cancel. Take grams out. Which should be.
How it should be.
All right, so that's B. Okay, let's move on to the next one.
After a question, before you see the answer.
What? Was I trying to find volume? We're trying to find mass, not volume. Why? Because I want grams. Yes. Similar mass. 99. 30 H2O? Hope not. All right, so calculate the number of moles in a spoonful of table sugar having the mass of. So, 10.5 grams. What do you do?
Divide by the molar mass.
Molar mass of. Wait. Caleb, we have a question. How do I help?
At least that's what that is.
Yeah. All right. So that's grams. That gets us to moles. What's the next step? That's it. Good. 10 divided by 3.42.
I think it probably would be 3.07 somewhere around there.
There's no decimal. 342.
.00307.
Yeah, so it's going to be C. that case, we're only trying to find moles. The first one, yes. Someone added up 12 carbons, 2,200. All right then, good. That's C. We're just trying to find moles. We're not trying to go past moles. In this situation, it's like, oh, there's a, wow, very white fuzzy puppy. You got a bath. All right, what is the gee, dog. What is the volume of 0.35 moles of oxygen gas at STP? How would you do this? Then is O2, however, the gas, right? And we're looking for a volume. What's the representative particle for oxygen?
What? What's the button?
What's the representative particle? It's a molecule. It's a molecule. Okay, it's a compound, so therefore the molecule of oxygen is what we're looking for. O2, we're going from moles to what?
Volume.
Volume. So therefore, what do we do?
22.4.
He's somewhere around 7 or 8.
All right. Good job. Now, that one actually recorded. Yay. All right. Now I want to give you a worksheet to work on that we can get done in class, I think. With any luck.